So jump discontinuity we did, infinite discontinuity. And the example was fx is equal to 1 upon x minus 2. So if you talk about a point limit x approaching 2 plus, suppose that is right of 2. So you can think of a value 2.0000. This is just to make you understand. Minus 2, 1 upon value something of like this sort, which will 1 by 0.000 dot 1. So many zeros are there. So reciprocal will be 1000. So it is a very large value. It is a very large value. In other words, if you are taking limit x approaching 2 plus fx, that is you are saying limit x approaching 2 plus 1 by x minus 2. So this will be infinity. Okay, because the value which is you are putting here is 2.0001. It can be further smaller than this. It can be further smaller than this. So you can put as small as it you want, and the difference between that value and 2 will become negligible. So the reciprocal of that will be a very large value, which is called infinity. Do you understand this, Sathya?
Yes, sir.
Okay. Similarly, if we talk about limit x approaching 2 minus fx. So here again, you are taking a value of x very close to 2, but on the left of 2. So x may be taken as 1.99999 many times. So when you take 1 by 1.99 minus 2, you will get 1 by minus 0.00. And this will be minus very large value, minus of very large value. So you can say that this is actually minus of infinity. You can call it as minus of infinity. So in negative side, it is minus infinity actually. So limit x approaching 2 minus will be limit x approaching 2 minus 1 by x minus 2, which will be minus infinity. That is negative infinity. Though here it is not asked to draw the diagram, but I just want to make it sure that you understand the concept. I'm drawing a diagram, but you don't have to draw it or you don't have to remember it. I just want to show you that if you draw this graph 1 by x minus 2 graph, this is the line x is equal to 2. When you draw this graph, it would be a graph which will be something like this. So you can see from the graph that as we see 2 plus, it will be plus infinity, and we see 2 minus, it will be minus infinity. Here it is going very, very, very large value. Here it is going very, very, very small value, which is minus infinity. And at 2, it is not defined. Not defined at 2. So this type of discontinuity is called infinite discontinuity, because the limit is not finite, it is infinite. So you can write this down. I will scroll down as you will see. Written something?
Writing, sir.
Hmm?
I'm writing, sir. Just
Okay.
the case scroll down. Yeah, done, sir.
With this graph also you have drawn?
No, I have to draw it. Yeah, done, sir.
Okay. Now there are few questions whose picture I have taken. So what were those questions? First is find the points where the following functions are continuous, right?
Yeah,
Continuous was it? It was discontinuous. No, continuous it was. So x square minus 2x minus 3 by x plus 3. So how to do these questions? Basically, x square minus 2x minus 3 upon x plus 3. Now, where is the function continuous? So since this is a rational function, right? Rational expression, polynomial in numerator and polynomial in denominator. So it is a rational function. Now here, all the points are okay. You can further say that in this, there is only one chance where it may be discontinuous. So doubtful point, we can call them doubtful point. We are not sure, but that point is doubtful. Can you tell me which point of x is doubtful point? Where the denominator becomes 0. That is x plus 3 becomes 0. That is x is equal to minus 3. There we need to check for continuity. Because for other points, it is continuous, no issue. Because it is a normal rational function. Other values you put 1, you put 3, you put 7, you put minus 22.5, whatever value you put, x belonging to any real number, Okay, it is continuous. You will get a value. It is not defined. But at x is equal to -3, it is not defined because denominator becomes 0. So it is a doubtful point. So we will say x belonging to R is continuous everywhere. This is called belongs to this found this belongs to. So x belong to real number, every real number. It is continuous except maybe at x is equal to -3, that we need to check. Now, how do we check it? So our process of checking was we want to factorize this. That means we want to find the limit. So limit x approaching 3 fx, we try to find out. Can its limit be found out? So limit x approaching 3 fx is limit x approaching 3 here. Fx, this numerator can be written as x minus 3 into x plus 1, that you can do by factorization, middle term splitting by x square minus 2x minus 3. Okay, by x plus 3. So clearly x minus 3 and x plus 3 are not getting cancelled here. We were hoping that agar we were getting x plus 3 in the numerator,
Yeah.
then there was chance of it getting cancelled, but it is not getting cancelled. So it is not defined at x approaching 3. It is infinity, or you can say, of x is approaching -3, not 3.
So,
Approaching minus. Yes.
so can we use the form, the b square minus 4ac, that one?
Why would you use that? Here it is not needed.
Okay,
Here we need factorization.
okay, yeah.
Here basically x square minus 2x plus 3 was minus 3 was there. So x square minus 2x minus 3. So this is x square minus 3x plus
Plus
x
x.
minus 3.
Yeah.
X. So this will be x minus 3 into x plus 1. So x square minus 3x plus x minus 3 हो गया. Now denominator is not x minus 3, it is x plus 3. So as we were seeing earlier, somehow it used to get cancelled, but it is not a condition like that. They are different. So if you put x as -3 finally, then what you will get, denominator as 0, and it will become infinity.
Okay.
So you will say that limit does not exist. And if limit does not exist, then it is not continuous also. So that doubtful point is a point where it is not continuous. So we will say it is continuous everywhere except at, maybe we can remove, and we are sure this we remove, and we'll say except at x is equal to -3. We don't need to check now. This we can say. Here it is discontinuous. Getting my point?
Yes, sir. So doubtful point means like
Point to check.
Okay.
Check
So
points.
This is for,
Continuity.
so if there is no points, there is discontinuous. So
It is only one point, x -3, where it is discontinuous.
okay.
That is the doubtful point, and we checked at the doubtful point, it is discontinuous. So all the points it is continuous except at x is equal to -3.
So is that, do we get that from the denominator?
Yeah, here we get that from the denominator.
Is it always in the denominator?
No, not necessary. We will see one more example where it is not from the denominator.
Okay, yes, sir.
It should be a doubtful point only if makes the function not defined. Because obviously, if you search for numerator will always be defined. So denominator when becomes 0, and x plus 3 becomes 0, then there is a chance that the function fx will be not defined. So that is why we take this as a situation here. But it
Okay.
is not necessary always in denominator function. We will have one more function which I take the picture just now. It will come later, but I'm telling it you here only so that you will be able to relate. Fx is equal to root over x minus 5. In the next slide to this, second part one, this question was there. So here it is not reciprocal, it is not in the denominator, but still here it is a square root. Now square root also lead to doubtful situations. Like if you have x minus 5 as negative, then it will not be defined. The square root of negative value, square root of negative is not real. It is not defined. It is not real actually. So x is less than 5 are all points where fx is not real. Now at x is equal to 5, what happens? Now if you want to check at x is equal to 5, so it is saying find the x values where the following functions are continuous. So at x is equal to 5, there is an interesting situation. F of 5 is equal to root over 5 minus 5, that will be 0. Root over 0 is 0. F of x, limit x approaching 5 plus is equal to limit x approaching 5 plus root over x minus 5 is equal to, if you put x as 5 plus, like 5.00001.
Yeah.
So it will also be 0.001, it will give you 0 overall. Finally, limit x approaching 5 minus x approaching, here is 5 minus f of x. Now this is not defined because this is less than 5, and we know that if x is less than 5, then all such points fx is not defined. 5 minus means simply it can be 4.999999, very close to 5, but still it is less than 5. So it is not defined. So since here the function is not defined, but since x less than equal to 5, it is defined and giving you real value. So we will say that it is continuous for real, sorry, it is continuous for x belonging to 5 to infinity, that is x greater than equal to 5. For x less than 5, it is not continuous. We'll simply say like this. So square root will also create doubtful points as a reciprocal create. So you can write all of them one by one. I'm starting from here. Is it okay, Sathya?
Yes, sir. So can you scroll down?
It is x approaching -3. It is not 3. You should not get
Okay, so
confused here.
yeah, I see that. I see that. So like, is there like a specific place where like, I mean like a type where we know that it's continuous and if it's not continuous?
Which a specific place you can find out. You are saying that.
Yeah, is that like, without like calculating this, do we know if it's continuous or not continuous by looking at the graph? Can we know that or?
Yeah, by looking at the graph, continuous simply means that it is without
It,
break.
okay, yeah. So I mean, if it exists and not exists, can we know that?
Yeah, from graph.
Yeah.
Yeah, if limit exists, then the right hand value and the left hand value will approach the same thing. And if limit does not exist, then they are not. Like I gave you an example yesterday. I'm just showing you that one.
I think I have it.
Yesterday, this example we had.
Oh yeah.
This example, okay. Here you can see first one in the first example. This one, limit exists because left and right both are approaching to the same point. And third one, limit does not exist because first is left is approaching to M, right is approaching to L.
Okay.
So limit both is discontinuous. This is also discontinuous. First is also discontinuous. Third is also discontinuous.
Only second is continuous.
So second is continuous. This is continuous. But in the first one, limit exists. In the third one, limit does not exist.
So why is the first one discontinuous? Isn't meeting at the same point?
No, that point is not included. No? That point is if you come to that point, like you are coming from left side, then you can predict that its value will be M at A. Okay, just focus on my statement. If you are coming from left to A, what value you will predict at A? That will be M you will predict at A.
Yeah.
But when you will reach A, will you really going to M or L?
When we reach, I think I will go to L.
When you reach A, then you will go to L. So limits does not talk about the exact value at that point. It talks about what is the prediction. So before reaching A, what was the prediction that it will become M at A? Similarly, if you are moving from the right towards A, then again, what was the prediction that if you will reach A, you are not reaching A, but if you will reach A, you will land to M. But
Okay.
actually, it is not landing to M. This is giving you left and right M, but at A, it is giving you L.
Okay.
Clear?
Yes, sir.
So, should I scroll next one?
Yeah, yes, sir.
Satya, how is your scheduling done? What are the days that is been given to you? 7 days or 6 days? How is it?
Oh, for me,
Mhm.
I think it's 6 days because I think they told Friday is off.
Okay. So just I wanted to know if actually I have to go somewhere this Saturday. So if I
Okay.
can shift your class on Friday, will there be any issue with you?
No, no, sir.
Okay, I will talk to them, and if possible, then I will shift the Saturday's class on Friday,
Okay.
and that will be conveyed to you by them. Okay.
Okay, sir. So can you scroll down? Bless you, sir.
Thank you.
So x is greater than equal to 5 defined. What is that after that?
And giving real value.
Okay. Yeah, answer.
Okay. So two more questions are there. Let us discuss them also. One was your, this question is f of x is equal to 4, x less than -2, x square, x between -2 and 3, x, x greater than equal to 3. So find the points where they are continuous. So again, the doubtful point here is 2. 2 points are where you have to check at x is equal to 2 and x is equal to 3. These are the doubtful points because there the function is changing, but we don't know about continuity or discontinuity. So we have to check at these points. So if you talk about x less than -2, this situation, limit x approaching -2 minus fx, left of -2. So limit x approaching -2 minus the fx is 4. So we know by the from the first property that here though there is no x, so simply 4 will be written as 4. You remember that limit x approaching a k is simply k. So because no x is there, so you will get k as k.
Okay.
limit x approaching -2 f of x -2 plus. So you have greater than 2. So greater than 2 is this situation. -2, sorry, greater than -2. So this is the situation, x greater than equal to -2. So this is x square. So limit x approaching -2 plus x square. So that will be -2 square. You will put -2 here and you get 4. So, and f of 2, what it will be? So at 2, exactly 2,
So
you
where was
have
this question?
to check for continuity.
Okay, yeah, I see. Yeah.
So at x is equal to 2, above one is not included, middle one is included. So x square. So that will be -2, it will be -2 square, that will be 4. So what we observe here, that the left hand limit and the right hand limit and the value of the function at -2, that is f of a, all are giving you the same output, 4, 4, 4. So left hand limit is equal to right hand limit is equal to function at the point limit. So it is
It
continuous.
exists.
At x is equal to -2. So -2 is a doubtful point, but this is -2, not 2. So -2 is a doubtful point, but our doubt got cleared, and it is not that it is discontinuous, but it is continuous at -2. Have you got this?
Uh, yeah, I think I did. So what about x equal to greater than 3?
Yeah, there we have to check. For
Okay.
-2, it is clear.
Yeah,
-2,
yes,
it
sir.
is continuous. Now at 3, we have to check.
Sir,
Yeah,
what about the right hand side in the second one? Isn't it 3? Isn't it greater than, no, yeah, smaller than 3?
yeah, that we will check. Smaller than 3 is the left hand limit of 3.
Okay, okay.
That we will do. So when we take now at x equal to 2, we want x equal to 3, we want to check. The limit x approaching 3 minus fx is equal to limit x approaching 3 minus fx, that is left of 3. So at the left of 3, we have x square. So this is x square. So this will be 3 square. That will be 9. Don't write it -3. 3 minus means left of 3. That means you
Okay.
have to finally put 3. It is minus does not mean here that it is -3. It means left of 3. Similarly, if you will take limit x approaching 3 plus f of x. So this will be limit x approaching 3 plus f of x will be for 3 plus x greater than equal to 3. It is x. So you will take x and then you put 3 here. So 3 you will put in place of x, you will get 3 only. And f of 3 will also be 3. That is, this is included now. X greater than equal to 3, x is there. So at 3 also it is x. So this will be 3. So here you can see that the left hand limit and the right hand limit and the value at the function are not all same. Left hand limit is not equal to right hand limit. And the right hand limit is equal to value of the function, but all three needs to be equal. So it is not continuous at x is equal to 3. So out of the two doubtful points, -2 and 3, one doubtful point got cleared, but another doubtful point, it is not continuous. So it is continuous at all x belonging to real number except 3. Is it okay?
Yeah.
So now you can write. Okay, have you written?
I think so. Okay, scroll down. So how's the LHL equals to RHL in this one? Isn't it 9 equals 3? So they're not equal, right?
LHL is not equal to RHL.
Okay, okay.
I've written here. LHL is not equal to RHL. RHL is equal to value of the function at A.
Okay.
That is why it is not continuous.
That's right.
Okay. So what we understood that at doubtful points we need to check, but it is not sure that at doubtful point it will be discontinuous. That we will confirm after checking. Okay.
Okay.
Now next one last question was fx is 1 by x square minus 9. So this is your, you have to find where they are discontinuous. So you will factorize the denominator and you will write it as x plus 3 into x minus 3. Can you write it like this?
Yeah. Yes, sir. This one, yes.
Now again here the issue is of denominator. So that denominator x plus 3 into x minus 3 should not be equal to 0. That means x plus 3 should not be equal to 0 and x minus 3 should not be equal to 0, which means x should not be equal to 3 and here minus 3 and x should not be equal to 3. So x can't be minus 3 and 3. These are the two conditions. These are the doubtful points. So what doubtful points we are getting? That x is minus 3 and 3. Now if you take limit x approaching minus, no, here you can do directly. What is happening here, that if you observe, no need to write all the steps. You can just see, if you take minus 3, suppose, so at minus 3, it is not defined. Is it defined or not defined at minus 3? It is not defined. If you put x is equal to minus 3, it will become 1 by minus 3 plus 3 into 3 minus 3, minus 3 minus 3. That will be 1 by 0 into minus 6. That will be 1 by 0. That will be not defined. Is it okay?
Yes, sir.
So this is not defined. So when it is not defined, then you can say it is discontinuous, because continuity means limit also exists and it should be equal to value at the function at that point. So why to waste our time in finding the limits when already FA is not defined? Then it is not continuous. So why to waste time in limit? If they were asking what is its limit, then we were calculating it left hand limit and right hand limit. Or if value of the function was defined, then we were calculating left hand limit and right hand limit. But here the value of the function is not defined. Then why will you calculate limit? Leave it. Don't waste time in that. Getting it?
Yeah.
Similarly, if you will take x is equal to 3 also, that is also not defined. So in that case, 1 by 3 plus 3 into 3 minus 3. 1 by 6 into 0, that will be not defined here. So it is not continuous here also. So you can
Okay.
say that the function, therefore, the function is not continuous at x is equal to plus minus 3. Okay.
Yeah.
So you can start writing from here.
So can I write the other one directly? The 1 by x minus 3 plus 3.
Yeah, you can, if you have understood, you can write that.
Okay, yeah, I'll write that. Okay, scroll down. So can you scroll down?